Hi learners, welcome to our new semester preparation. We welcome you all to our September-December semester, especially CIFA students who are doing the practical paper. So I want us to just look at a concept here. Under portfolio management, we do it from scratch and then we'll be able to answer a question which was tested in April 2024. So the financial management and data analytics students, those who are doing the CIFA practical paper, this is what you need to do. So go to your browser of any choice and then you type the word Yahoo Finance. Just type the word Yahoo Finance. It will take you to this section here. So we pick Yahoo Finance, stock markets. Stock markets, we want to look at the stocks and of course the history or historical data. So I'll come to this part here, finances. You come to market and then you pick stocks. I want us to three. So the first one, we are going to use, can pick the first three. So you can start with this one here. Once you click on that, get to historical to get the option of downloading the financial history. So when you get to historical data, you can see the option of downloading is already provided here. The option of downloading is already provided here. I want us to do this for the, so basis here, we want to pick the monthly basis. We want to pick the monthly basis and take the 5-year data. So I want to take the 5-year data. So once that is done, you automatically come to this place and download. So get to that place. Get to that place and download. So you actually download it. You can see it up here. Open it. That's the first one. Then we go back again and download the second one. We go back to download the second one. We go back to download the second one. So I'll come to still under markets here. Pick the most active still, most active. Most active. We now go to number 2 this time round. Our number 2 is Tesla. So just click on Tesla. Just click on Tesla. So once you do that, pick the 5-year. But of course, even before we go to the 5-year, we want to go to historical data so that we get the download option. So go to historical data. Historical data. We pick monthly arrangement. Monthly arrangement. We want to pick the 5-year again. 5-year interval. 5-year interval. Good. And then you download the second one. We have been able to download the second one. We have been able to download the second one. So once that is done, good. So we've been able to download Tesla. Let's go to the third one. At least three can enable us to do this analysis. So let's go to the third one, market. Let's get back to market. We go to markets here, most active. We are now looking for the third one. We are now looking for the third one. So the third one, we are going to take this one here, Rocket Lab. So we get to Rocket Lab, go to historical data, go to historical data. The 5-year interval is very important. So we take the 5-year interval. It must be uniform. The data you are extracting here must be uniform. That's why we must take pattern. So we come here and under duration, we take monthly data over the past 5 years. Over the past 5 years. So you come here, pick the monthly option. Pick the monthly option. Then you now download. We now download it. Good. So having done that, we have been able to download the 3 stocks. So assume your portfolio has got these 3 stocks. Investment A, B, C. So for our case, we have Rocket, we have Tesla, and of course we have Nvidia, right? So I want us to use those 3 to be able to look at the performance of this particular portfolio. I want us to use those 3 to look at the performance of this portfolio. So this is what we are going to have. This is what we are going to have for our discussion. This is what we are going to have. So I want us to use maybe we can use this. So let me just share the document. Let me share my screen with you here. Rocket, so we have this. We have Rocket. So if this is the Rocket, remember the date is the same throughout. The date is the same throughout for our data. Now, this is what I want us to consider. We can take either opening stock price for all the 3. We can take high price for all the 3. We can take low price for all the 3, closing price, or even volume. But now I want us to use adjusted closing price for all the 3 stocks. So remember, date will be the same now that we've been able to extract data under the same range. I don't need this other columns. I don't need volume. What I need to do is, now that this data relates to RKLB, right? That is Rocket. We have been able to take the adjusted. So we are going to take also this one here, Nvidia as a stock. We bring it then Tesla. We also bring Tesla as a stock here. So let's bring the adjusted price for the other 2. Let's bring the adjusted price for the other 2 from the documents that we have been able, that we are able to download. So pick the adjusted price, let the pattern be common. Let's have a constant pattern. Let's have a constant pattern. So that is a Tesla. I think that's what I've taken. Tesla. Yes, that's Tesla. So let me paste Tesla data here. Tesla. I need to get Nvidia. So Nvidia as a stock. We also need to take adjusted closing price. Adjusted closing price. Nvidia. Good. So that's what we have. We can now save it. So the first thing we need to do is to look at the return. So how do we get the returns? Now we copy this and express the returns as a percentage. Express the returns as a percentage. So what we need to put in place is, it is the most recent price divided by, that is the current price divided by the previous price minus 1. So if I look at 1st of December 2020 and 1st of January 2021, which one will represent the current or most recent? Of course, it is 1st of December 2021. So for me to do my analysis, this is what we are going to do. You need to take most recent divide by previous, which you can see we don't have, but we refer to it, minus 1 to express it as a percentage. We are looking at the percentage change, right? So if that is done, you'll be able to see we are having an error. But that error is not a mistake. Let's just scroll it down. You'll be able to see now it is taking most recent, which is 1st of January 2021, dividing by the previous one, which is December 2020 minus 1. So that's what we have. So always, if you're going to deal with your data, just know this one here will not be having any value. That's why we have the error. Alternatively, in some questions, you'll be given the most recent year, like the latest, like this one here we have 16th. So the whole of this month is 16. So you can also have this, rearrange your data, rearrange your data using the dates here. So you start from 16th of August all the way to 2020. Good. So I can see there's a slight difference. My data here, I need to pick for KLB, I need to have the arrangement. So it means we download the document which does not have the monthly arrangement. That's why you can see we have some error, slight error here. It is not picking the monthly arrangement. So that is a straightforward thing. Very fast. We go back to our data source, that is the Yahoo. We get back to Yahoo. Here and look at this. We need to pick the 5-year. We need to pick the 5-year and do it on monthly basis. So once that is done, we download a fresh one. Let's download it here very fast. It cannot stop us from doing the right thing. So of course, maybe in exams, the examiner will give you this data. But I want to show you how, when the raw data is given to you, you should navigate through to get to the analysis point. So we'll come here. Good. So once the download is complete, we get to extract the adjusted closing price. We get to extract the adjusted closing price. Adjusted closing price. So our adjusted closing price has already arrived. Adjusted closing price has already been extracted. We'll come here. And paste the right one. Good. So having done that, you can now see we have the right arrangement. Let me just go with that so that we have the right data here. So let's kill B1. Good. Now, if you look at this data, we're able to see this particular portfolio has got only 1 year data. It does not have the 5-year data. So it will force us to get back and pick a new portfolio. Let's go and pick a new asset or stock which is going beyond the 5-year duration, Let's locate and even take Amazon. Let's look at this part and locate Amazon. Now that this one here, so Rocket does not have 5-year data. It was just recently to the money market or to the stock market. So let's look for another one that will be able to cover all that duration. So you can even take Apple. Apple is okay. Yes, so let's come to this part. Let's have Apple. Apple has been there for the longest time possible. So we go to historical data. We go to historical data for Apple. Historical data for Apple. So we take the 5-year, very important. Ensure you have the 5-year. Ensure you have the 5-year. Then, of course, we pick monthly historical data. Monthly historical data. Sometimes it normally takes a little bit more time to extract the data. Good. So you can now see, let's give it time to give us the monthly output. Monthly output. Yes. So once that is done, we can now download the Apple. So Apple will replace our Rocket. Apple will replace our Rocket. Good. So we can see Apple is perfect. Apple is perfect. So we just come and take. We can actually use this Apple. Now that Apple is okay, we just need to pick, remain with the adjusted closing price. So I want to talk about Apple, and then we bring the other two stock. So from the other document, we can bring in. Let me show you now my screen at this point. Good. So this is now the data for Apple. So let's bring the other two that are okay. 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 The other two, we bring it to the Apple folder or Apple document here. And of course, we paste. So as long as we've been able to pick the right date range for all the shares or stocks, then you can automatically see it stops at the same point for all of them. It stops at the same point for all of them. Good. So having done this, we now have 3 assets or stocks. So the first thing we need to do is to get the return. So what did I say about return? I said return is equal to the most recent divided by the previous one, which is not there for this date. Then we minus 1. You can see we have an error for the first one. It is not a mistake. What you've done is actually perfect. Then we autofill. So it is only this first one which will be having an error because you don't have the previous periods data. That is now the month of August 2019, right? So that's why we have an error for the first one, and of course, that is allowed. Having done this, we've been able to look at the changes. We've been able to look at the changes. So these changes, we normally express them as a percentage. We normally express them as a percentage. So I come here, express as a percentage to 2 decimal places will be okay, good. So having done that, I want us to get some key items about this data. So let me just put it here for us to be able to get them perfectly. So the first thing that I want us to get is return, expected return of individual stock. So if your portfolio has got these 3 assets, we need to get expected return, we need to get variance, and of course standard deviation. So how do we get expected return? Expected return of a portfolio, of an asset, is equal to the average. These are the expected returns, right? So we get the average. And remember, these figures are on monthly basis. So if we want to get annualized expected return, we take the average and then we multiply by 12. So how do we get this? Equal to average of expected returns of apples. I come and pick this, all of this range, right? That's the average. We close the bracket and multiply by 12. We want to get the annualized. Annualized expected return of the 3. So once you autofill, you can see we actually have them here. So by doing that, you can express them as a percentage. Good. About variance equal to, we have that option, variance. So what we are having here, remember, is not the entire data for this stock. Apple is not for this stock. NVDA is not for this stock. Tesla. What we are having here is a sample. So we take the variance formula for the sample, not population. Population is the entire stock, which we have not extracted. We only extracted for 5 years. So what we are having here is a sample. And therefore, if you want to calculate variance, we look at the variance of a sample. I want us to pick number 1. So again, come to this part. Close the bracket, and of course our variance will be multiplied by 12 months. So that's our variance. For this particular asset. So if you did portfolio management at intermediate, at advanced level, you can perfectly recall that standard deviation is the same as risk, and of course is the square root of variance. If I get the square root of variance, then automatically I will be having standard deviation. So I'd simply come here and say equal to square root of variance. Come to this part and pick square root of variance to give me standard deviation. That's the standard deviation of this particular investments. So we have this stock 1, stock 2, stock 3. We have now expected return of individual stocks. So once that is done, I want us to have some assumptions here. I want us to have some key assumptions here. I want us to get, so let's have here risk-free rate, risk-free rate. I want us to have, we can have 3% as the risk-free rate. What we need to get here, we need to get expected return of the portfolio. we need to get variance of the portfolio. We need to get standard. We need to get standard deviation of this particular portfolio. Our interest here is to maximize, to get that which will maximize the returns. So it means we'll be having what we call, we'll be calculating what we call a Sharpe ratio. So we need to calculate Sharpe ratio. So at some point, we'll be calculating what we call Sharpe ratio. It will give us the optimal frontier or efficient. Yeah, good. So having done that, now for us to get expected return of our portfolio, it will be summation of weight and expected return of individual investment. So let's get the weights. We need to have weights here. We need to have the weight. So we are going to extract these three assets. We have them in that order. Then you get the weight. Weight here, we can assume that they have equal distribution. So equal distribution, there are three numbers, so each will be having 1/3, 1/3, 1/3. We can have it all the way to this, but good. So that when we get now sum of the weights should add up to 1. Sum of the weights should add up to 1. And of course, we can express them as a percentage. We can express them as a percentage to decimal places. Good. That's what we have. Now, how do we get expected return of our portfolio? Expected return of our portfolio is equal to weight multiplied by expected return of individual assets. So we need to get the summation. So we can use these two formulas. Number one, we can use multiply. That is, you double multiply, right? I will transpose this, right? Multiply, then we transpose. Because the arrangement is not the same. This one is arranged in a column. This one's here arranged in a row. So we want to transfer this to be in a row and then multiply. We want to transfer this to be in a row and then multiply by the arrangement of the expected return of individual assets. So that's why we are transposing. I believe you understand the concept of transpose. I want us to transpose this way. We close that bracket, comma, then we multiply by expected return, and then we close our bracket. So once that is done, let's see where the problem is. Good. Let's see where the issue is. That's option one. Of course, we're going to use the two, as I've said. The second one, we can use sum product. We can use equal to sum product. So sum product, we take this, then multiply by this other one. It is summation of the multiplication results, right? So we'll be taking sum product, we'll be taking this, then we multiply the second array. We can now talk about transpose. Then we pick this, close the bracket, and then close the entire bracket. So if that is done, we're able to see we have this. Alternatively, let's back up and look at this. We can decide to transpose the last one. So we can decide to transpose the last one. We pick this one here. We multiply by transpose. So we are going to transpose this one here. We'll be transposing that one. Oh, so there's a problem with our data arrangement. There's a problem with our data arrangement here. Good. So to avoid that, we can actually use the third method. Let's do the third method. So our third method here is equal to, we take weight of apple, we multiply by expected return of apple, we add weight of NVDA, we multiply by NVDA, then we add weight of Tesla, we multiply by expected return of Tesla. At the end of the day, you can see we are getting the same thing. We are getting, if you express this as a percentage, you express this as a percentage, you can actually see we are getting the same thing. We are getting the same thing. Good. So having done that for the expected returns, we need to get variance over portfolio. So how do we normally get variance over portfolio? For us to get variance over portfolio, then it means we must have covariance or correlation coefficient. We must have covariance or correlation coefficient. So if we add only two assets, that is this one and this one here, could have just come here to calculate correlation coefficient or covariance, right? So for us to calculate covariance, equal to covariance, correlation coefficient. So of course, you have the array 1 and array 2, which is just two assets. But now we have more than two. So if you have more than two, we are going to calculate variance. And of course, we need to have covariance results somewhere. So the first thing we are going to do, let's have our covariance here. Let's have our covariance output. Let's have our covariance output. So the covariance here, it is a 3 by 3 matrix. We are going to have our assets here. We are going to have our assets here. We need to get covariance. Good. Now, another thing that we need to remember is when I look at this part, I have three. So I will keep on referring to this range, this range. So for those who are in our advanced Excel class, we talked about cell referencing, 100% cell referencing by creating a name from the selection. So what are we going to do? We just come and highlight this, do it all the way to the last part. Then I go to formula, create from selection. So we're going to create name from the topmost row, right? So within what I've selected, the topmost row will be the name of that particular range. So just come and say top row. Then I confirm. Good. So having done that, I've been able to create a name for that. For example, if I now highlight this, you'll be able to see it is giving me the name of that range. It is giving me the name of that range, right? So we'll come here to calculate covariance. So equal to covariance. The covariance I want to get is for a sample, not population, right? So I come to covariance S, that is the sample. What do I need to do? I need to pick an array. My array, you can see I'm comparing apple and apple, right? So what am I going to do? I just type A. You can see automatically it's appearing, comma, and it's highlighting that range, comma, apple. I'm comparing the two, the same thing, right? Good. Having done that, remember I'm doing it for 12 months or for the entire year, but this one is giving us on monthly basis. So what do I need to do? I need to take this and multiply by, 12, and that and multiply by So having done that, very simple, just sort of fill it to the last part, then I show you something good. Now, having done that, I can come to this part. If I come to this part now, I'm comparing NVDA and Apple. So Apple and then NVDA. So come and replace this with NVDA. NVDA. Good. Come here. It is Apple and Tesla. It is Apple and Tesla. We have Tesla there. Come to this other one. So we are talking about NVDA throughout. It is now NVDA. NVDA against. So we have this NVDA against NVDA against NVDA here. That's Apple, correct? This one here we have NVDA. Then we have NVDA against Tesla. NVDA against Tesla. So here it's very simple. Look at where we have. It's the same thing. It's normally the same thing. So look at where we have Apple and Tesla. So just come to Apple and Tesla. It's the same as this one here. Look at where we have NVDA and Tesla. So you look at NVDA, Tesla, we simply refer to this. And of course, at this point, look at where we have Tesla and Tesla. So I just come to this part and say it is a Tesla and Tesla. Tesla and Tesla. Good. Having done that, we now have the covariance output. We now have the covariance output. Good. So with that, we can actually go ahead and get variance. We can actually go ahead and get variance of this particular portfolio. Remember, portfolio has got more than one asset. So that's why we have the 3, at least 2. But now for our case, we have decided to take 3. Good. So with this, we can actually calculate variance. We can actually calculate variance. So how are we going to calculate this variance? Remember, variance is equal to standard deviation of individual assets squared multiplied by its weight squared plus 2 weight of asset 1, asset 2, asset 3 multiplied by covariance of A. Multiplied by covariance of the assets that are given there, right? So already we have the covariances. We already have the covariances here, which again, they're going to multiply by we are going to add or multiply by the weight squared and standard deviation squared of individual assets. So to avoid that root, or to be able to deal with this is what we are going to do. This is what we are going to do. So how do we get variance? How do we get variance? How do we get variance? So our variance here, now that we have covariance, we are good to go. So we'll be having equal to multiply, right? Then we have multiply again. So array 1, we take the weight, we take the weight here, right? That's the first one. But of course, even before we take the weights, we need to transpose. We need to transpose it first. Because remember, our weights are arranged in a column, but this covariance is arranged in a row. So we need to transpose this. We need to transpose our data, right? So the first array, we pick the weights. We pick the weights, having transposed our weights, comma, right? We pick the weights, comma, array 2. We pick all the covariances that are here, pick all the covariances that are here. Then we are done with the first multiply, comma. Then this time around, we take the weights, but now we don't transpose, right? We don't transpose, and then we multiply, and then we multiply. So by doing that, we now close the bracket. We now close the bracket. So that's our variance. So with the variance, how do we get standard deviation? It is the square root of variance. So it is square root is equal to square root. Square root of variance will give us standard deviation. Will give us standard deviation. So how do we get Sharp ratio? So our Sharp ratio here is equal to expected return of this portfolio minus risk-free rate. Then the result should be divided by standard deviation of our portfolio. Should be divided by standard deviation of our portfolio. Standard deviation of our portfolio. Good. So having done this, you can now see we have Sharp ratio. But what should be our weight so that we maximize this Sharp ratio? We get the optimal weight. How can we get the optimal weight of this particular investment? So that's where we now get to use what we call solver as a function in Excel. So let's go and see how we are going to apply solver to maximize on the returns of this particular portfolio by maximizing the weights, right? I mean, maximizing the Sharp ratio. So this is what's going to be our point of interest. Let's put it that way. So how do we activate? Most some people are not having this solver function in the Excel. So how are we going to activate this solver? How are we going to activate this solver? So the first thing I'm going to do, right? The first thing I'm going to do, you get to file, more options. I believe you're able to see what is happening. So once you get to more options, go to add-ins. Then instead of the go sections, just click on go. And then you come to this part. So ensure that solver add-in is actually marked. This box here is marked. If I do that, it will not appear. So for those people who are not having it under data, it means this box is not marked. So please mark this box to activate it, and then you confirm. So once that is done, you'll be able to see when you now get to data, here, you'll be able to see. If you get to data, you'll be able to see solver is appearing here. So our solver will enable us to, we want to put a condition whereby we are maximizing this Sharp ratio with an intention of looking at the optimal weights. We want to look at the optimal, weights. So with this, it will be very, 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 very simple. So I want us, remember, weights also cannot exceed 100%. Our weights cannot exceed 100%, right? So let's go to solver. So click on solver. If you have anything you delete, you can reset all. If you have any, yes, we reset any. Good. So let's come to this part. Our objective here is to maximize. What do we want to maximize? We want to maximize Sharp ratio, because by maximizing this, we'll be able to get the optimal weights. So once we multiply that by changing variables, so the variables that are going to change is this weight, because with the weights, we can actually optimize our investment or returns for this particular portfolio, and of course, minimize on risk, right? So we want to maximize on the Sharp ratio by interfering with these weights. We want to set the constraints, right? Even though we are going to change the weights, they must not exceed, the summation of all the weights must not exceed 100%. So I'll come here and add that constraint. So my constraint here is to say that the summation of the weights should be equal to 100, should be equal to 100%. Once that is done, I just add it. And of course, you can now see my constraint is already set. So the next step is to do what? Is to solve. With that condition, I'm required to solve, right? So then you confirm for the second time to be able to see. Good. So it means we can just have zero investment in Apple and have NVIDIA and Tesla having these weights for us to be able to maximize. So you can see we have this sharp ratio of 1.60, which is the optimal one by looking at the effect of these assets here. Good. So with this, we should be able to look at the expected return of the portfolio and standard deviation, because we are going to draw efficient frontier chart of this particular investment, efficient frontier chart of this particular investment, right? Good. So with that, the next thing I'm going to do, I'll be coming to this part and having a list. So this is the optimal sharp ratio. And of course, the optimal weights, we have the three of them here. We have 0 weight for this. We have 84.39. We have 15.61, right? Good. And you can see we've actually been able to minimize on the standard deviation, the risk, right? So this one here is a more riskier asset, which or stock, which we've been able to do what? Which we've been able to, as per the optimal analysis that we've been able to do here, it is eliminated. But of course, that should not affect you. So long as you're able to optimize this, whether it is 0 or even 0.44, don't be worried about that. That is what the optimal results has actually given you. Unless you want to put a constant that this one here must be greater than 0%. Then you can now look at another arrangement. But again, that arrangement will not give you the optimal sharp ratio. Good. So with that, I want us to come up with what we call efficient frontier chart. So efficient frontier chart will enable us to come up with a graph that will be helping us to deal with this. So the first thing I'm going to do is to have expected return, and then we have standard deviation. Of course, we all know that standard deviation is the risk of the portfolio, expected return of the portfolio. We can actually have it as expected return of portfolio, standard deviation of the portfolio. Good, I believe you're able to understand that. Now, with this one here, I will come to this part. And look at individual assets, expected return. So we have 33, we have 81, we have 78, but now our optimal expected return of this particular investment is 80.63. So look at the lowest. Let's look at the lowest expected return. So we have 33.04, right? 33.04. We can actually have these expected returns to be arranged somewhere. That is the lowest. For your information, this is the lowest. And then the highest is 81.04. So I want to have a pattern whereby we start with the lowest and move all the way to the highest. Lowest all the way to the highest by maintaining maybe a common interval. So what if we have one to take us a long time? But let's see what we can have. So start from the lowest, maintain the interval, and of course get to this particular point. So we can decide to have it at this point. We can decide to have them at this point, right? We can decide to have them at this point. So we start with the lowest. This is the lowest, and of course, this is the highest. I want us to maintain that by doing this. I want us to maintain that by doing this. Let's look at increasing this by 1. So from 3, we go to 4, right? So we having this one here plus 0.1. Yes, we can have that. We can have that. Let's see where it will take us to. Let's see where it will take us to. Yes, so we need to have that again. Plus 0.1. Good. So where we have 0.78, I need to fix it somewhere so that it can appear here. So at this 0.73, we can have now 78 come here. We can now have 78 come there. Then we have 0. This one here. Let's make it to be part of this at this point. And of course, the highest one, let's bring it here. So at least we've captured all of them. We've captured all of them. Now, we know very well that at 0.806, this one here, it's standard deviation. So these are the expected returns, right? These ones are the expected returns. So we want to see its standard deviation at this point is equal to this. We've been able to calculate it. And remember, I want to refer to it without having any formula. Without having any formula, so I want to copy, then paste the value only. Good. Now, with this, I want us to come to the lowest. I want us now to have an intention of getting our expected return of the portfolio to be at this. So this is the constant we are going to insert there. So I come to this part. We want to distort our solver here. I want to distort our solver here. I want to distort our solver here. So we come to solver. This time round, we don't want to, okay, this one is there, but we want to add another one. So this is another one. We want to set expected return to be equal to, we're going to do that all the way to the last one. So when we put our expected return to be equal to this, we just need to add. Then we solve. So let's come and solve it here. Let's solve it there. So when we solve it, this is the standard deviation. So this is what I want us to pick. This is what I want us to pick. So at that point, we are having that in place. Let's come and pick this one here. Let's come and pick this one here. Make them to be without the formula. Good. So let's come to this one. The second one, we do the same thing. We copy. We get to solver. We get to solver. We get to solver. Look at this condition. We edit it. We have the option of changing it. So this one equal to, we now take a new value, which you've just copied there. We adjust it there. Then we solve. So when that is solved, you can now see it has changed our standard deviation to this figure. Standard deviation to this figure. So place the value, right? Then we do it also with this other form. So let's do it together. Let's do it together. Let's do it together. I can see we've now been able to get the point. Okay, sorry for that. We can now proceed. We can now proceed. Good. So we have this one here. We've been able to bring the standard deviation. So let's come and pick this. You can actually see how this concept is very, very straightforward. So once you pick that, you go to data, pick your solver. Our next point of action is here. We change this to be equivalent to. Then we confirm, and then we solve. Let's solve it. Let's solve it. Let's solve it. So standard deviation at that point is equal to that. Let's come and pick this one again. Let's come and pick this one. Let's come and pick this one here. We go to data, solver. We are almost done. So we come here, change it. Change it to this. We confirm. We solve. Once we have been able to solve, I pick the standard deviation there. Put our standard deviation, get to third last. So let's have this. Go to data, solver here, go to solver. We change this. You can actually see there's nothing complex about this particular model. So once that is done, we have been able to solve. We solve our new standard deviation is that one here. As you paste, remember we have copied a question or an answer with the formula. So when you come to this part, you paste values only. So you can just go to this and paste values only. That's what I've been doing. Let's go to second last. We pick this. We pick that one. Then we go to data solver. Right? Come and pick this. We change. We paste this there. Then we add. We solve. Good. So we've been able to solve. We copy. We paste it there. We go to the last one. We go to the last one. We go to the last one here. That is this. So we come and pick this. We come to solver under data. We come to solver under data. We change that condition. We change that to this one here. Confirm. We solve. Confirm it there. And then we are good to go. So once we copy the standard deviation, I have that standard deviation here. I have that standard deviation here. Good. So we now have expected return and standard deviation. So remember, don't forget to take it back to the right place. I just come now this part here, solver. We go with this other condition. Good. So we get to this part, and this time around, remember we introduced this condition to help us get the varieties. So we need to delete this condition, right? We need to delete that condition. Once that is done, of course, we now solve to get it to the optimal point where it was. And of course, that optimal point was 1.606. Good. So having done that, our efficient frontier curve will appear in this particular order. Our efficient frontier. So I'll come to this part here. I'll come to this part. We need to draw this. We need to draw this in our efficient frontier curve. So just highlight that, go to insert. We want to insert a scatter graph. Of course, we have this scatter graph, right? So this is what we have as the efficient frontier. Let's see if we switch the columns. You can see that's not working. So we come to this part here, come to this part and select data part. Yes, select data part. This is what we are having. Alternatively, I can remove all this, come to this part, add. So what do I want to add? Serial name. So our serial name is what we call efficient frontier curve. Then X values. X values, we pick expected return here. Then Y values, we pick these ones here. Right. Pick these ones here. Remove these, we pick the Y values. Good, I think that is okay now. And then we are good to go. So having done that, you can now see we have the efficient frontier. We have the efficient frontier. Alternatively, you can come to this part. You can come to this part here. So that is what we have. There's no harm if you take standard deviation to be there. Then we take expected returns. Let's have it in this one to appear in that part. Actually, this will be the right one for us now. Then we confirm. So by doing that, you can see how it is appearing. It should start from somewhere here, right? From somewhere here and go to have that shape, right? So that shape is actually perfect for us. So you can actually change it again to this pattern. Even have this in place, even this in place, whichever. As long as you're able to do it to this point, you'll get your full marks. You'll get your full marks for this particular question. So this is what you are required to do. This is what you are required to do with regards to portfolio management. With regards to portfolio management. So I just want to show you a question from the past paper, that is April 2024, that you see whether you're able to go through. So just create time, listen to this video, and of course attempt April 2024. And of course attempt April 2024. So please find time and look at April 2024, question number 23. So you are given the securities. Of course, you can remember what we are having here. So the first thing you need to consider is the date. So like you can see here, we have 1st of July, we have 1st of August. So it means here, let me just give you an hint. For you to get the expected returns or the returns here before you get to the average, you'll be taking the most recent. You can see this is the most recent date, right? We divide by the previous date, then we less 1. So that's how we need to deal with it. That's how we need to do. It means if you do it this way, the last one, let's see if the last one will be there. Someone has already forgotten what we did. Now, you can see the first one. The first one, we should not have a figure for the first one. Why? The most recent is August 2021 compared to July. So when I come to under July here, I should take the most recent, which is July divided by the previous one. Where's the previous one? It is not given somewhere here, right? Put there and then we less 1. So by doing that, we all expect that the first one we are going to have an error. And that is not a mistake. That's what should be there. If you have an error for the first one, that is the right thing, right? If you have an error for the first one, that is the right thing. So once that is done, you can decide to put them as a percentage or not. Still, there is no harm about it. So these two we just eliminate. So we have the 2 securities here. That is A and B. That's what you need to do, right? To be able to do that and get the average, for you to be able to get the expected return of individual portfolio standard deviation, right? Covariance. We have been given the weights here, you can see. We have been given the risk-free rate. So we have all the items that we used in the other demonstrative question or illustrative question. So we have the security weights that are not given here with these ranges here. Are you able to get something, pick something from it? Yes. And then you give us what we call the Sharpe ratio and the optimal risky portfolios, mean and standard deviation. So that's basically expected return and standard deviation of the portfolio. And then you give us the curve here. So please attempt that. And of course, we are looking forward to meet you in our next semester's class, which is beginning on 2nd of September 2024. Thank you and have a great time.